All right, guys, let's start off here on number 2. So for this one, I see that this is an explicit formula because we don't have any subscript and really our variables in the exponent here. So that means if we want each term, so if I want the first term, I call that a sub 1. I'm just going to go ahead and plug in a 1 for n. Now, I just need to evaluate here. So that exponent is kind of implied parentheses there, so it's 4 times 3 to the 0 power. So that's really 4 times 1, and so that would be 4. So then a sub 2, same idea, just plug in 2 for your variable there. And so that'll be 4 times 3 to the first, and that's going to be just 4 times 3, which is 12. And then a sub 3 is going to be 4 times 3 to the power of 3 minus 1. So it's going to be 4 times 3 squared, so 4 times 9, which is 36. And then a sub 4 will be 4 times 3 to the power of 4 minus 1, which is just going to be 4 times 3 to the third, which that is 27 times 4, which I don't know off the top of my head. So that's 108. So those are my first 4 terms there. All right, next up here, number 4. So for this one, I see that this one is recursive. That little sub n minus 1 right there tells me that it's recursive. Also, the fact that they're telling me the first term is also another indicator. So what I'm going to do here, I already know a sub 1 is negative 39. So then I'm going to go a sub 2 equals, and I just take the previous term and plug it in there and then add 7. So that's what that a sub n minus 1 really means here, is previous term. So since they gave me that first term, I just have to plug that in to find the second term. So that's going to be negative 32. A sub 3 then will be that new previous term. So now I'm going to plug in negative 32 and add 7. So each time I'm just adding 7 to the previous term. That's going to be negative 25. And so a sub 4 is going to be negative 25 plus 7. And so that's going to be negative 18. And that's it. Now remember that this is actually, these are the first 4 terms. I include the one that they told me about, and then these 4 right there. That first term, even though I didn't have to find it, still is the first term. All right, next up we got number 6 here, and this one's actually kind of a mix. So it actually has an explicit piece in that n right here, and then also it has the recursive piece right here. That a sub n minus 1 referring to the previous term. So I do have the first term here. So then for the second term, a sub 2, I have to plug in a 2 for the n part, for the explicit part. And then for the recursive part, I plug in the previous term, which is 1. So that's going to be 2. So then for a sub 3, once again, the explicit part, since I'm looking for the third term, I plug in a 3 right there. And then the recursive part, I now plug in the previous term, which is now 2. So that's going to be 6. So I'm just taking this piece and plugging it in right there, just like I plugged that piece in right there. Whereas this piece really matches whatever subscript it is that we're doing at the moment. So then a sub 4, that first piece is going to be 4, just matching up with that explicit piece. And then the recursive piece is going to come from the previous term, which will be 6. And so that's going to give me 24. So my first 4 terms are 1, 2, 6, and 24. All right, next up here we got number 8. So for this one, we're wanting to write an explicit formula for this sequence. So I'm just going to try to track the pattern here. So I see that this is just like a +4 pattern, +4, +4. And so whenever that happens, I kind of think of this like a y equals mx plus b. And so that 4 really is the slope right there. So I'm going to say a sub n. Actually, I'll just do this as y actually. So I'm going to do y equals 4x. And then I have to think right here, because if I plug in a 1 here, I need to be able to get out 10. So that means that this must be a 6. So I can, and then I'll just kind of translate this into the a sub n form. So 4n plus 6. I can just test it out here. So when I do a sub 1, I get 4 times 1 plus 6, which is certainly 10. So that one checks out. And then a sub 2, I get 4 times 2 plus 6, which is 14. So that one checks out as well. All right, next one here, I see that these are all fractions, except this one right here, but actually I kind of noticed that this one I would probably write it as negative 25 over 5. And so when I look at it like that, I see that the numerators, or actually I'm going to say that it's always a negative out front, and then it's always 25 in the numerator. They did simplify that one right there, but I actually like looking at better as negative 25 over 5. And so then the denominator I see is increasing by 1 every time, so I'm going to say that that's n plus 1. So I can check it out here by saying a sub 1 equals negative 25 over 1 plus 1, so that certainly checks out. A sub 2 equals negative 25 over 2 plus 1, which certainly checks out as well. All right, next up here, we're going to write the recursive formula for each sequence. So recursive formula, remember, first of all, we need to say what a sub 1 is. That's actually the easy part. So for a sub 1, I'm going to say it's 7. And then the next part, I'm going to just say a sub n equals a sub n minus 1. So remember that what this means is that the next term is always defined then as this one is the previous term. And then you describe the pattern. So I see that this pattern is a plus 100 pattern, so I'm just going to write here plus 100. So that is my answer. I do need to include that a sub 1 as part of that. All right, next up here, number 14. Once again, for the recursive formula, I'm going to list a sub 1. And then for a sub n, I have to just say it's going to be a sub n minus 1, and then track the pattern. Looks like a plus 10 pattern. So I'm just going to say plus 10. All right, next up here, number 16. So for this one, we want to evaluate the series. And so I'm just going to have to list out all the terms. So I always start with whatever number is on bottom here. So I'm going to do a sub 1, which is 3 times 1, which is 3. A sub 2 is 3 times 2, which is 6. A sub 3 is 3 times 3, which is 9. And a sub 4 equals 3 times 4, which is 12. A sub 5 equals 3 times 5, which is 15. A sub 6 equals 3 times 6, which is 18. And then a sub 7 is 3 times 7, which is 21. So now, since this is a sigma or a series, I need to add everything up. So I'll go ahead and do that. I'm going to see if there's any numbers that are easy to add up here. Yeah, I'm going to grab these guys. So that's going to give me 30. And this 9 and the 21 will also give me 30. Let's see, 15. These ones are going to give me 9, and then I still have that 15 right there. So now I just have to add all of these up. So that'll be 60 and 70, 84. All right, same idea here. We just need to get all those terms. So I'm going to start off with a sub 1, which is 1 times 1 minus 1, which is 0. A sub 2 is 2 times 2 minus 1, which is 2. A sub 3 is 3 times 3 minus 1, which is 3 times 2 is 6. And then a sub 4 is 4 times 4 minus 1, which is, let's see, 12. And then a sub 5 is 5 times 5 minus 1, and that is 5 times 4 is 20. So now I'm going to stop there, since that's the top number. That's the term we stop on. And so now we're going to add all these up. Let's see, this is going to give me 20, and 20 is 40. All right, next up, we're going to rewrite these in sigma notation. So first of all, I kind of need to think of an explicit formula for this. So I'm going to do that first. I'm going to call that 1 over 1. And so when I do that, it looks like the formula here is 1 over n. Since that denominator keeps changing, I'm going to call that n. And so now I'll stick that in a sigma. And so we'll start off at n equals 1, and then we're going to go all the way to 5, since that's really the last number we have there, of 1 over n. All right, next up here, I got this one. Looks like here we got, what is that going to be? Powers of 4. So this is 4 to the first, 4 squared, 4 to the third, and 4 to the third. Or sorry, 4 to the fourth. And so my formula then is going to be 4 to the power of n, and I'm going to do that from n equals 1. Which is really my first term here when you plug in the 1, and we're going to stop at the last one, which is me plugging in a 4. All right, next up here, this one is actually another, these are a recursive formula. And I know we don't see the little a sub n minus 1, but actually on this one we see the a sub n plus 1 in front. So what that's saying is that if we want to find a sub 2, we're going to do 2 plus a sub 1 over 2. So you can see that this front here, if this is 2, then this would be 1 less than that, so that would be 1. So it's still saying the next term here is based on the previous term. It's saying it in a slightly different way, but it's really not that different. So yeah, so it's the same idea we were doing before. So I can take that first term, which is 10, and plug it in right there. So I get a sub 2 equals 2 plus 10 over 12, so, or sorry, 2 plus 10 over 2. So I'm just going to call that 12 over 2, which is 6. And then my a sub 3 is going to be 2 plus the previous term. So I'm going to take that 6 that I got right there and plug it back in, all over 2. So that's 8 over 2, which is 4. And then for the fourth term, I'll just do the same thing one more time. 2 plus, and then take this one, 4 all over 2, and that's going to give me 3. So my list is going to be 10, 6, 4, 3. All right, again here, another recursive formula. So it's saying to get the next term, take the previous term and multiply by -3. So I'm going to say to get a sub 2, I'm going to take the previous term, which is right there, and then multiply by -3. And so that is going to equal 3. And so for a sub 3, I'm going to do the previous term again, times -3, so that's going to be -9. And then for a sub 4, I'm going to now take that previous term, -9, and multiply it by -3, which is going to give me 27. So I have then my list is -1, 3, -9, positive 27.